In this demonstration, you learn how to enable and disable the Save button based on the fact if the friend model has errors or not. Let's switch to Visual Studio. Before we implement the logic, let's run the Friend Organizer application. I select a friend and I remove the first name. You can see we get a validation error, but the Save button is still enabled. Now I show you how you can change this. Let's open up the friend detail view model that has the save command that is used by the friend detail view to save a friend. Here in the constructor of the friend detail view model, you can see how the save command property is initialized with the new delegate command. The delegate command uses the onSaveCanExecute method to detect whether the save command can be executed or not. So I right click here and I say go to definition. Here in this method you see we just return true. But we have a to-do comment, check if friend is valid. So instead of just returning true, I check if the friend is not null, and I also check if the friend does not have any errors. Now let's change this to-do comment, check in addition if friend has changes. We will implement this in the next module so that the save button gets only active if the user has changed the friend. But now here we have ensured already that the user can't save the friend if the friend has errors. Now we just need to ensure that this onSaveCanExecute method is called. This method is called when we raise the CanExecuteChanged event on the command. So let's scroll up a bit to the loadAsync method where we initialize the friend property with a new friend wrapper. After we have initialized it, we take our save command and we need to cast it into a delegate command. And then we can call the raise_CanExecuteChanged method on it to raise the CanExecuteChanged event. But we also need to raise that event when the hasErrors property of the friend wrapper has changed. So here we can install an event handler for the property changed event. And we just use a lambda expression. And we say if the property name is equal to the hasErrors property, then we also want to raise the CanExecuteChanged event of the save command. So I just copy this line and I paste it here into this if statement. Now we need to ensure that the hasErrors property raises a property changed event when it has been changed. But when does it change actually? It might change when we raise the errors changed event in our notifyDataError info base class. So let's go to that notifyDataError info base class. I scroll down a bit and here we have the onErrorsChanged method to raise the errors changed event. When we raise that event, we can call from the viewModel base class from which we inherit here the onPropertyChanged method and we raise a property changed event for the hasErrors property. Now if we did everything correctly, it should work. And I'm sure we did everything correctly because you and me, we are doing pair programming here. So let's run the application. I select a friend and now I remove the first name. You can see the save button is disabled. As soon as I start typing, the save button gets enabled again. And the same is of course true for other errors. So if I specify here an invalid email address, the save button gets disabled, and as soon as I specify a valid email address, the save button is enabled again and I can save that friend. Now you have seen how to validate with custom errors and how to validate with data annotations. Let's wrap up what you have learned in this module. In this module, you learned how to implement the iNotifyDataError info interface in a base class. You have also learned how to display errors with an error template, and you have seen how you can validate by using data annotations. With the validation in place, we were also able to enable and disable the Save button in the Friend Organizer application. Only if the friend is valid, the user can save it to the database. In this module, you have also learned how to create a basic model wrapper to set and get properties of the wrapped model. If you want to learn how to create a more advanced model wrapper, I recommend you to watch my course WPF and MVVM Advanced Model Treatment. In this course, you'll learn how to create a model wrapper that even tracks the changes to all the properties. This allows you to display changed fields in the UI with a different color and to display even the original value of a changed field in the Tool tab. The next thing that we do in our Friend Organizer application in this course is to detect model changes by using Entity Framework's DB context. Welcome to the module Detecting Model Changes. My name is Thomas Claudius Huber. In this module, I will show you how you can use Entity Framework to detect if the user has changed a model or not. You can use this information, for example, to enable the Save button only if the user has changed the model. Before we start, let's take a quick look at the module outline. The first thing that you learn in this module is how Entity Framework tracks changes. With this knowledge, we are able to plan the lifetime of the Entity Framework DB context in the Friend Organizer application. We will create and use a friend repository that wraps the DB context and that has an hasChanges method. This hasChanges method will return true if the models in the DB context have any changes. In the Friend Detail View model, we will use this friend repository and we will enable and disable the Save button if the model has changed or not. We will also block the navigation from a changed friend so that the user is aware that he will lose his changes if he navigates away without saving. Let's start now by looking at how Entity Framework tracks changes. In the Friend Organizer application, we have created a Friend Organizer DB context. Such an Entity Framework DB context has a change tracker property. This change tracker property is read-only and it returns a DB change tracker instance. A DB change tracker has an hasChanges method that returns true or false based on the fact if the entities have changes or not. So all the entities that you have loaded over the context are tracked by the DB change tracker. Beside the hasChanges method, the DB change tracker has also an entries method. This method returns a collection of DB entity entries. A DB entity entry has an entity property that points to the entity for which it is used. So in our case, this will be a friend instance because the friend class is the only entity type that we have in the Friend Organizer application up to now. The DB entity entry instance has also a state property that is of type of the enumeration entity state. That enumeration has the values unchanged, modified, added and deleted. It also has the value detached if the entity is not tracked by the context. The DB entity entry class has also the properties original values and current values. So you can actually find out what has changed on an entity. But in the Friend Organizer application, we don't want to find out what has changed on an entity, we just want to find out if the entity has changed at all. So we can use the hasChanges method of the DB change tracker. But the DB change tracker will only work if we keep the Friend Organizer DB context alive, so that it can track the changes made to its entities. In the current code, we create a DB context for every action that we take. Let me show you this by taking a quick look at the SaveAsync method of the Friend Data Service. As you can see, the SaveAsync method of the Friend Data Service takes a friend instance as a parameter. Inside of the method, we create a DB context by using the context creator func. So we have here a brand new DB context instance that doesn't know anything about the friend instance that is passed to the SaveAsync method. That's the reason why we have to attach the friend instance to the friends DB set of the context, and then we have to grab the DB entity entry of this friend instance by calling the entry method of the DB context for this instance. This entry method returns a DB entity entry, and on that DB entity entry we set the state property to modified. Now the DB context knows that this is a modified entity, so it will send an update statement to the database when we call the SaveChanges async method. But all these steps, attaching the entity and setting the state, wouldn't be necessary if we would keep the context alive so that it could track the changes on the entity on its own. This means for us now, we shouldn't create a context for every action like we have it here. Instead of doing this, we should keep the DB context alive a bit longer. But how long should we keep it alive? Let's plan now the lifetime of the DB context in our Friend Organizer application. The Friend Organizer application has a client-server architecture. That means Entity Framework's DB context is used on the client. And this allows us to control the lifetime of the DB context so that we can use its change tracking functionality. So now let's plan how we want to keep this DB context alive. Let's just look at what we have now. We have a friend detail view model in the Friend Organizer application that is using a friend data service. The friend data service is injected into the friend detail view model's constructor. The friend detail view model contains load logic to load a friend. This load logic just calls the getById method of the friend data service. The getById method creates the Friend Organizer DB context to load the friend entity from the database. The friend detail view model contains also the logic to save a friend. That save logic calls the save logic of the friend data service, and the friend data service creates again a Friend Organizer DB context to save the friend to the database. Now, as we just create a Friend Organizer DB context here for every action, we can't use the change tracking logic. To use the change tracking logic, we need to keep the Friend Organizer DB context alive through this load and save cycle. So in this module, we will change this. We don't create the Friend Organizer DB context multiple times here. Instead, we just inject it into the Friend Data Services constructor. That means the Friend Data Service has a single Friend Organizer DB context instance. This allows us to create a hasChanges method in the Friend Data Service that just calls the hasChanges method of the change tracker of the DB context. As the Friend Data Service is using now the same DB context instance across its methods, it's now a stateful service. That state is the reason why I want to rename the Friend Data Service to Friend Repository. The name Friend Repository makes it more clear that this object is stateful. Now anyway, let's don't start a discussion about names here. With the hasChanges method in the Friend Repository, we can also extend the can-save logic in the Friend Detail View model. We can enable the Save button only if the model has been changed. Now the next thing that you do in this module is building the Friend Repository together with me.